Assalamu alaikum everyone. This is Mohammad Sabir Ahmed Shubho. My ID is 242156545. Today I will present my project called 4-bit binary to decimal display using 7447. This project is about converting a 4-bit binary number into a decimal digit. The output is shown on a 7-segment display, which is the type of display we often see in the digital clock and the calculator. In this system, I use 7447 IC, which is BCD to 7-segment decoder and the driver. This IC takes binary input and convert it into the signal that control the segment of the display. Uh, to give input, I use the push switches where each switch represent on bit. So by turning switches on or off, we can create the binary number from 00 to 11. It also use resistor and uh, proper right proper writing to make sure that the circuit works safely and correctly. Next slide. And here is our team member. First, Mashrafi bin Noor Shadia, then Nusrat Nisha, then Zarif, and me. Next slide. Now the goal and the visualizing binary number. Now I will explain the main goal of this project. The goal is visualize binary number is simple way. Many people find binary number difficult to understand, so this project help by showing their decimal equivalent. In this system, we give a 4 binary input using switches. For example, if we input 0000 on, the display show on. If we input 100 on, it show 9. The 7447 decoder convert the binary input into signal that light up the correct segment on the display. On input part of this project is understanding how the circuit behaves with the uh, invalid input. This project focus the three main things: decoding binary number and proper uh, writing of the component and understanding the circuit behavior. That's all for mine. Thank you.
Now,
Hello everyone, it's me Umen Nusrat Nisa. My ID is 242-15168. Today I'm going to talk about the key components and the 7447 IC of our project 4-bit binary to decimal display. In this slide, I will talk about the key components used in our project and how each of them plays an important role. First, we have the push switches. These are 4 momentary switches which are used to manually set the binary inputs A, B, C, and D. Each switch represents 1 bit. When we press a switch, it connects to VCC and gives a high signal, and when it is not pressed, it stays low using pull down resistors. These allow us to control the input values easily. Next is the 7447 IC, which is the core component of our system. This IC works as a decoder. It takes the BCD inputs from the switches and converts them into appropriate output signals for the 7-segment display. It basically acts like a translator between binary numbers and human readable digits. Then we use a 7-segment display, specifically a common anode type. This display is used to show numbers from 0 to 9. It contains 7 small LED segments labeled from A to G. By turning on specific segments, we can display different numbers. To protect this LED from excess current, we use resistor with each segment. Finally, we have the wiring and power system. All components are connected using jumper wire. We supply plus 5 volt to power the circuit and connect all grounds properly. A small capacitor is also used for decoupling, which helps to keep the voltage stable and reduce noise. So overall, these components work together to take binary input and convert it into a visible and numeric output. Moving on the next slide, which is 7447 IC. Now let's understand what is 7447 IC actually works. The 7447 IC is a BCD to 7-segment decoder. Its main function is to convert binary coded decimal inputs, which range from 0 to 9, into signals that can drive a 7-segment display. It has 4 input pin named A, B, C, and D. Here A is the least significant bit and D is the most significant bit. Based on the combination of this input, the IC determines which segment should be turned on. we can see on the output side it has 7 pins labeled A to G. Each of these corresponds to one segment of the display. The interesting thing is that the output are active low. This means when the output signal is slow, the corresponding segment lights up, and when it is high, the segment remains off. Another important feature is that the 7447 is designed for common anode display. In this type of display, all the anodes are connected to plus 5 volt. The IC completes the circuit by pulling specific segments to ground, which causes them for light up. For example, if we input the binary value for 5, the IC will automatically turn on the correct segment to display the number 5. So in simple terms, the 7447 IC makes it very easy to convert binary numbers into a visual numeric from without complex programming for manual control. So that's all from my side. Thank you.
Assalamu alaikum everyone. My name is Mashafi bin Noor. My ID is 242150076. So I'm going to talk about the overall circuit and how we can build it. So this is the breadboard, and you can see already what we have used. We have used pull down resistors, push switches, pull up resistors, 7447 BCD to 7 segment display, cathode display, and jumper wires. We all need this for this project. The next slide is how the wiring for the push switches works. So our push switches has 6 pins. So we can connect them with one wire or one pin. We can use the connect input for VCC, or we can use the pull down using the GNT. We will get in the next slide. The next slide shows how the blueprint or step by step how the circuit will work. So we have to connect the push switches. We have to connect the connecting wires with the push switches. We have to connect the whatever you can say, the resistors, the LED lights, the IC, and moving on. So this is the power the IC or VCC, or we can see how we can power the IC up. So to do that, we can already see there is a plus and there is a minus. And to power up, we need a battery, or we can have a DC connection or anything like that. So when we power up the battery with the positive or negative, the VCC connection goes to the positive and it comes here and it powers up the IC. So for the first 4 switches, we can see these are connected with the brown wires, and these wires, another wires are coming from the pins, and it goes for the first switch, it goes to 7, the second switch, it goes to 1, the third switch, it goes to 2, and fourth switch, it goes to 6. So after connecting those IC pins, we can see we need to connect more of them from the IC. So we can see how we have connected them. We have used our resistors here, and we have connected them parallelly. So the top of the breadboard is active as well as the bottom of the breadboard. So you can see for the 50 number pin, it goes to the pin 9. It is not actually pin 9. We are displaying it as pin 9, so we can understand it easily. It is actually pin F. So it goes to pin 9, pin 14 goes to pin 10, pin 13 goes to pin 7, pin 12 goes to 6, 11 goes to 4, 10 goes to 2, 9 to 1. So that's how we will power up the cathode display. Thank you very much.
Assalamu alaikum everyone. I'm Sadia Islam. My ID is 242150084. This slide shows the signal flow of our system from input to final display. First, we have the input stage where the user sets a binary value using switches. These switches represent a binary coded decimal. Next is the decode stage. Here, the 7447 decoder interprets the BCD input and converts it into signals that correspond to specific segments of a 7-segment display. Then comes the drive stage, where the decoded signals are sent to the display with the correct voltage levels, ensuring each segment turns on or off properly. Finally, we reach the display stage where the 7-segment display shows the corresponding decimal digit. It's important to note that valid BCD inputs from 0 to 9 produce correct digits, while invalid inputs may result in blank or undefined patterns. Overall, this flow ensures accurate conversion from binary input to a human readable number. This slide shows the behavior of our system for non-BCD inputs, specifically values from 0 to 15. As we know, BCD is only valid for numbers 0 to 9. When inputs go beyond this range, the 7447 decoder cannot correctly decode them. Because of this, the 7-segment display may show undefined results, such as blank outputs or random segments lighting up. In some cases, certain segments may remain off or turn on incorrectly, which leads to confusing or incorrect display patterns. To make the system more reliable, we can add extra logic to detect these invalid inputs and either blank the display or show an error indication. This helps ensure that only valid numbers are clearly displayed. Thank you.
Hello everyone, my name is Irfan Masood Zarif. My ID is 2421509. Now I will talk about the demonstration plan and troubleshooting. First, step-by-step demo. Here, the cycle switches from 000 to 1001 to verify digit from number 0 to 9. Pause on invalid course to show behavior. Then second, common issues. Incorrect writing, missing ground, wrong display type, or missing register, etc. are checked in a datasheet pinout. Third, the tips. Here, the level wires use color coding for VCC and ground, and test each segment by forcing output with jumper wires before fully assemble. Next. Now, I will talk about the next step of extension. Automate inputs with a counter IC, for example, 7490 to cycle binary values automatically. Second, drive multiple digit with multiplexing for 2-digit numbers. Learn about multiplex drivers. Third, compare 7447 to other decoder or drivers and explore using microcontrollers for more flexible display. Thank you everyone.